If you've ever watched a space battle on screen, you know the drill. Engines roar, brightly colored lasers streak across the void, and enemy ships erupt into massive fiery explosions. But actual space is a near-perfect vacuum. Without air or any other medium to carry mechanical vibrations, an explosion is completely silent. And because there are no atmospheric particles to scatter light, a laser beam is entirely invisible until the exact moment it hits its target. This diagram illustrates the only physically viable way to simulate weight on a spacecraft, centripetal acceleration. You have to spin a massive cylindrical habitat to create an outward force. The standard sci-fi trope where astronauts walk normally on flat, static floors without rotation relies on fictional gravititic plating that defies physics. NASA actually pays close attention to these details. They maintain running evaluations of how accurately Hollywood portrays physics, heaping praise on the technical fidelity of historical dramas like Apollo 13, while actively debunking the science of blockbuster disaster movies. Most space movies break physical laws to keep the plot moving. The films that earn the highest praise from the scientific community use those inaccuracies deliberately, not to avoid hard work, but to heighten the drama within the realm of the possible. Let's start at the bottom with the lazy cheat. This happens in movies like The Core or Armageddon, where writers sacrifice basic geological and physical principles just to set up an apocalyptic threat. Take Armageddon. The entire plot revolves around drilling into an asteroid the size of Texas and splitting it in half with a nuclear warhead to avoid an Earth collision. To actually split an object of that mass and push the halves far enough apart, you would need to generate roughly 800 trillion terajoules of energy. For context, the largest nuclear bomb ever tested by humanity, the Tsar Bomba, released a little over 400,000 terajoules. The movie's math misses the reality of human energy output by a factor of roughly 2 billion. Lazy cheats rely on completely nonsensical math. By asking the audience to ignore basic logic to make the plot work, they destroy the intellectual stakes of the film. A step up is the aesthetic cheat. This occurs when directors consult with actual scientists and understand the correct physics, but intentionally alter them to serve the audience's visual or emotional experience. When producing Interstellar, the filmmakers brought in theoretical physicist Kip Thorne. He provided the visual effects team with equations for general relativistic ray tracing to generate the most mathematically accurate visualization of a black hole ever created. But director Christopher Nolan took that accurate math and tweaked it. He reduced the black hole's rotation speed and removed the Doppler shifting that would have made one side of the accretion disk much brighter than the other, simply because the true image was too asymmetric and confusing for a general audience. Similarly, the film Gravity blatantly violates the conservation of orbital momentum. When George Clooney's character detaches his tether and drifts away to his death, a single tug from Sandra Bullock would have easily pulled him back in a weightless environment. Scientists and audiences tend to forgive aesthetic cheats. The physics are bent explicitly to ensure we understand what we're looking at, or to deliver a devastating emotional blow, rather than out of sheer laziness. At the very top of the hierarchy is the calculated cheat. The prime example here is The Martian, widely considered the gold standard of hard sci-fi and praised by NASA for its rigorous problem-solving. The movie nails the details. It correctly depicts the 8-month travel time to reach Mars using current chemical rockets, and accurately shows protagonist Mark Watney using an intensely exothermic reaction to extract water from rocket fuel. This visualization compares Earth's atmospheric density to Mars, highlighting the single glaring inaccuracy that sets the entire plot in motion. The Martian atmosphere is incredibly thin, about 1% as dense as our own. Because wind force is determined by velocity and density, a 120-mile-per-hour Martian storm only carries the dynamic force of a 12-mile-per-hour breeze on Earth. It might rustle a flag, but it is physically incapable of tipping a 20-ton ascent vehicle. A moment of wonder. Author Andy Weir knew this, and he used it anyway. He deployed one calculated cheat to strand his protagonist, creating an isolated environment where every subsequent challenge is solved strictly by the scientific method. This establishes a suspension of disbelief contract. We are willing to accept exactly one impossible inciting incident, as long as the protagonist has to follow the laws of physics to survive the fallout. Mark Watney honors that contract. He survives by relying on mathematics, engineering, and agricultural science to grow food in toxic soil. NASA monitors these films because popular media directly impacts public interest in STEM fields. When a movie gets the science right, it educates audiences and inspires the next generation of engineers who will actually build these spacecraft. This high-level collaboration on films like Europa Report ensures that even when a filmmaker takes a shortcut to drive the plot, the rest of the mission is built on the same engineering principles used at the Jet Propulsion Laboratory. Powerful space cinema signs a specific equilibrium between physical reality and narrative license, using enough truth to ground the story and just enough fiction to ignite our curiosity about what is actually out there.